Okay, so this is going to be the solutions to our Chapter 2 review packet. One of the first topics is kind of our angle pairs, and it's the angle pairs um, that either pertain to one intersection, which could be from one intersection, we could be looking at linear pair, or vertical angles. And when we go to, two lines cut by a transversal, we could get our other five that we studied. So you could have corresponding, you could have alternate interior angles, we could have alternate exterior, consecutive interior, or consecutive exterior. So those are the angle pairs that we're going to choose from here. So let's go through and look at that. All right, so we're going to start with angle 1 and 7. All right, so first we want to highlight those. So it's this angle, there, and there. Okay, now it's going to be alternate exterior. 1 and 7 are on opposite sides of the transversal. Okay, they're not in the same intersection, so it's one of these. It's going to be alternate exterior. Okay, so where am I going to put that? Angle pair. Okay, we can't squeeze it in there. So for 1 and 7, it should say angle 1 and angle 7. We're going to pick alternate exterior angles. Okay, the relationship is there. Maybe that's what they're looking for there. Probably that's what they're looking for. And what's going to happen is, so that's the relationship. And then equal or supplementary, we're going to say, in that case, if the lines are parallel, those are going to be equal. Okay, we'll go with angle 3 and angle 7. All right, so let's get rid of that. All right, this time angle 3 and angle 7. Okay, it looks like they're going to be corresponding angles. Yes. Same position on the other intersection. They're both on basically the bottom right-hand corner. So those are going to be corresponding. And those are also going to be congruent or equal. All right. All right. So back at this one, let's see. So now we go angle 4 and angle 6. All right. Let's get rid of this. 4 and 6. Okay, so it looks like this angle here and this angle there. Now what I'll teach these students is when you've got these two angles, look for the N or the Z, and kind of you can see it right here. There's a Z going on right there. That's usually going to indicate alternate interior angles if they're in those corners. Okay, of the Z, or it's going to be N when it's turned the other way. Okay, so that's going to be alternate. The relationship is they're going to be alternate interior on the other side of the transversal and between the parallel lines. If the lines are parallel, the relationship is they're going to be equal. All right, so now we're back on, let's go with angles 4 and 5, right? We're on this one. All right, so angle 4 and angle 5. What we have here is, this is your consecutive. I'll just put a star on those. Those two right there, those two angles are your consecutive interior angles, and those are going to be supplementary or add to 180, right? All right, so keep going. Let's see, we're on 8 and 6. Okay, let's get rid of some of that. 8 and 6 are vertical angles, so they're on one intersection. See, I'm looking at this one right here. So they're on one intersection, you're going to pick either linear pair or vertical angles. If it's one angle from two different intersections, we're going to pick one of these five, maybe. Okay. In this case, angle 8 and angle 6, they're on one intersection. Those are going to be vertical angles, and those are equal. Okay, they don't need parallel lines or anything like that. Last set is 4 and 1. Let's take a look at 4 and 1. Go back up here. Okay, so those are a linear pair. Okay, they're next to each other on the same intersection. That's going to be the linear pair. And those are supplementary. Okay, so that's that for number 1. Fill in the chart for that. All right, so AD is the angle bisector. We got to really pay attention of angle BAC. Even if it didn't say angle bisector, if it's bisecting an angle, we've got to produce two congruent angles. So what you'd want to do is let's trace the angle BAC, and what they're saying is that this line cuts that perfectly into two equal angles. So this angle right here, B to A to D, should be congruent to the other half, D to A to C. All right, so A's answer, what must be true? We know for sure that angle BAD must be congruent to angle DAC. And that's a definition of angle bisector. I won't write that because they didn't ask for it. Okay? Now, if AD is perpendicular to BC, now let's consider that. Okay? The segment B to C is what is being cut into two equal halves. So what we get is we get segment BD is congruent to segment DC. All right. If A, oh, I missed that one. I'm so sorry. That's actually, I did C. Let me back up. Okay, I messed that up. I did C on B's. Let me try that again. So, let's go back. It says AD is perpendicular to BC. Completely missed that. Perpendicular to BC. All right. So with that happening, what we get instead, if AD is perpendicular to BC, what we end up getting is right angles. The symbol we should put in the diagram is right there. Okay, so this is a little tricky. Angle BDA, so angle BDA and angle CDA are right angles. So perpendicular segments give us right angles. Sorry about that. Now we'll go back to C. Okay, now we're on the bisect. Okay, let me do that one now. Okay, so we've got the bisect portion now. If AD, this line right here, segment right here, bisects BC, then BC gets cut into two perfectly equal segments. So this is a segment bisector. The result is BD is congruent to DC. All right. Now these are really critical steps right here because they're going to be future proof statements that we write. So we got to get used to this. Last one, AD is the perpendicular bisector of BC. So what must be true? That's basically putting B and C together. If AD is the perpendicular bisector of BC, first we get those right angles right there. Okay, so first angle BDA and angle CDA are right angles, and so we get two things. Segment BD is congruent to segment DC. Okay, so we'll keep the videos to under 10 minutes. That's our first one. Signing off on this video.